We're looking at topic 12, congruent triangles. We're going to start with 12a. We're identifying corresponding parts of congruent triangles. So triangles are congruent if all the sides and all the angles match up. The triangle will have the same shape, the same angles, but it may be facing in a different direction. So what we're going to do here is figure out which sides match up with which sides, which angles match up with which angles. So let's start with the angles first. If we look at angle C down here, so if we look at angle C, we have two angles that are congruent. We would have angle C congruent to angle F. If we look up at the top, we have angle B, and it's going to be congruent to angle E. So we would have B is congruent to E. Go on the side here, we'd have A congruent to D. In addition to all of the angles being congruent in congruent triangles, these sides are also congruent. So this here side A would match up, and if we go ahead and name them in our original triangle, this would have been side BC, and in our new triangle that's congruent to it, we have EF. If we look here at the bottom, what's labeled side B, we had side CA is congruent to FD. And our slanted side here, it's labeled C on one of the triangles, is side BA, and it's congruent to side ED. We want to write a congruent statement for our two triangles. If we were to start with the first triangle, we could name that either triangle ABC, CAB, or BCA. We're going to just start with it being triangle A. Actually, why don't we call it ABC? That seems to make a little bit more sense to us, doesn't it? ABC. And it's going to be congruent to triangle. We need everything to be in the same spot. So if we start with angle A on this side, we're going to start with angle D on our new triangle. And angle B is congruent to E, so that's going to go next. So we're getting here DE, we're comparing C to F. So we have triangle ABC is congruent to triangle DEF. In addition to those angles all matching up, where A and D were in the first rows and they were congruent, we also have our sides matching up. So we had A and B together, and you'll notice here we have A and B, and it's related, congruent to E and D, which is also our first two sides in our triangle. We'll work like that on all sides and all angles. Let's look at angle 2 here. Something kind of interesting with angle 2 is that they no longer look exactly alike because one's pointed in the other direction. But I want you to see that it doesn't matter which direction they're in. If I flip it over, I do have a congruent triangle. So what I want to be able to do on my original triangle is think about what it's going to look like when it's flipped over and what it's going to match up with. So let's start with the ones that are labeled already, our two right triangles in the middle. So now they're touching or right next to each other where before they were not. We're going to match up angle C to angle F. Okay. The ones at the top of our triangle will match up A and D. And then you'll see angle F, when we flip the triangle, moved all the way over here to angle B, and those two become congruent. So we had F equal to angle B. Okay, if we were looking at the sides, let's start with the bottom. We had BC, and it would be congruent to EF. When it's going up and down, we would start here with AC, and it's congruent to DE. And then our slanted lines would be AB is congruent to DF. Okay, if we wanted to match up what these triangle names are, remember we're matching up the angles and the sides. So we could call the first one, let's see, we could call it triangle. We could go with ABC again. It's going to be congruent to triangle. With A, we line up with angle D. This should have been B and F that way. Let's fix that there. That should have been B in the first triangle and up to F on the other one. A and D and C and E. I'm sorry about that. It's hard to read what's going on here. That should be an E at the bottom. So B would line up with F and C with E. We have our triangle. We're not always given a triangle. Sometimes we're just given the name of the triangle. So let's use some highlighters to see if we can help figure this out. We said they're all going to be in the same position. So our first angle, angle E, is going to be equivalent or congruent to angle H. And our second in a row here, F, will be congruent to angle G. And our third in a row, I, will be congruent to angle I. Okay, so angle E we know is going to be congruent to angle H. What about the side FE? We see those in the first two spots. So on our second triangle, it would be the letters in the first two spots. HG or GH, either way around. So angle EFI goes in order. Here EFI, and we'll relate it to angle HGI. They will be congruent. FI is on the last two, so we would say it's congruent to the last two in the name, GI. And FIE, this one looks a little bit different, but it's 1, 2, 3, going middle, last, first, so we would start with middle, last, first, or GIH. And IE goes from last to first, so we would go with last to first, IH. And if we start filling in our box here for what is going to be congruent, we had triangle EFI, congruent to HGI, and that's where we would match up. This was our yellow, this was our green, and that was our blue. Okay, let's look at 12B, which is writing a congruent statement for the triangles. So sometimes we're given triangles with sides or angles congruent and we want to match them up. Remember that they're not always in the same position. Sometimes they're rotated or flipped around. And it looks like that's what's going on with this triangle. If we flip it over, we see that it's congruent this way. Our angles match up that way. So we want to keep in mind that we're taking this triangle and flipping it or reflecting it when we start trying to decide what is congruent and what isn't. We have a lot of markings that should provide some help to us. We can start with our one marking on the angles. Angle B is going to be equal to angle F. Okay, we can start naming here. We know B and F will be in the same position. Angle A here has 3 marks, and it will be congruent to angle E. Remember, we saw that when we moved the triangle over, that E E became where F is, so they are congruent. So our next one would be A and F. And then our two angles here. Two angles is G. And on our first triangle, it was C. So we have triangle BAC congruent to triangle EFG. Let's finish filling in our angles and sides. This is this angle that we're missing here. C is congruent to G. And now let's look for sides. We can do this with our tick marks. Our first side that we have one tick mark on is AB. You see it here, middle to the first. And here we have E and F, or F and E. I think I'm missing part of a letter there. So AB was congruent to EF. If we're looking at two tick marks, we had AC congruent to GE. And lastly, our three tick marks are BC, and it's congruent to FG. And if we went through the exercise of matching up each side, we'd see they're all in the same order. For instance, AC, our middle and last, is equivalent to GE, our middle and last. Okay. Let's look at another example where we want to write a congruency statement. Okay, we can see from all our tick marks what matches up with what, and we want to be able to get it into our diagram and label and name our two triangles that are congruent to each other. So let's start with our angles. Our one tick mark angles are A and D, and we can start off by putting those in the first position of our name. We have our two tick marks, B and F. Notice how they're not in the same position, right? So this is a triangle that gets flipped over upside to top to bottom rather than left to right. We have here B is congruent to F, so we can label the rest of it. And then we have three tick marks here on C, and it's congruent to E. Three tick marks. We now have the names of our triangles that are congruent, and let's match up our sides. One side is AC, the other tick mark is DE. Let's see if that makes sense here. First and last, and first and last. Sure does. Two tick marks is AB, and the other triangle, it is DF. So we had AB and DF. They're in the same position. And our three tick marks is CB and then EF. Those are both in the last and the middle position. So we would write our triangle statement as triangle ABC is congruent to triangle DFE. Okay. Topic 12C, we're going to be able to mark up some of our diagrams to show when they're information that's given. And there's also sometimes information that isn't given that we still know. We're going to see that in the first one. We have sides that are the same marked, and we also have angles that are the same marked. But what I want you to see is that this side in the middle that is the same for both triangles is also congruent. If you were to pull those triangles apart, they would both have the side that's congruent. That side was part of both triangles. And the reason we can say that that's the same is by the reflexive property. This is that weird property when we were doing algebraic that said something like x equals x or a equals a. Never felt quite right to us. Like, why would we need to use that? This is why. Okay, so moving on to the next one, we're told that C is the midpoint of AE and BD. So that knowing that it's the midpoint allows us to put in tick marks saying that each of those are congruent because it's the midpoint. There is something else that we can show in this diagram though, and that's that we have two angles that equal each other. And the reason that we can say that those angles equal each other is because they are vertical. Okay, let's look at our next example. Our tick marks that were given here show us that we have two sets of parallel lines. Okay, we're going to use those parallel lines to use some of our relationships that go with parallel lines, like alternate interior, alternate exterior. We're going to prove that those are the same. So we would use those to show that we had congruent angles. We could know that both of those are congruent. And the reason that we know that those are congruent is because they are alternate interior. We could also, on this diagram, mark that that side is congruent, and that would be, again, because of the reflexive property. Okay, let's look at the next diagram. We again have markings showing that some of our sides are congruent, and we could add that our angles are because they're vertical. Okay, we're going to move on to topic 12D, which is where we talk about included angles. Included angles and included sides really just mean that they are angles or sides that are between the others. So included angles are between two sides, and included sides are between two angles. You can see the diagrams that you have on your page and on the screen here what we mean here. We have a side, and in the middle of it is an included angle. We have an angle, and the middle of it is an included side. Okay, we're asked what is the included angle between B and C. So it's asking us for these sides between B and C, the included angle would be angle A. What's the included side between angles C and B? Here we have C and we have B. And the included side is side A. Side A. Okay. We're going to move on to topic 12E, which is how we can justify that triangles are congruent. So we said in the beginning that it had to have all six things. Three angles and three sides have to be congruent in order for a triangle to be congruent. But there's some shortcuts that we can take. We don't have to prove that all six of those are in existence. If we use one of these theorems, one of these 5 theorems that we have, we only need to prove 3 of those things are congruent. And then if those are, our angles are automatically congruent. We call these 5 that we can use side, side, side. We abbreviate it SSS for side, side, side. And that means that if 3 sides, you can prove that 3 sides of the angles are congruent, then the triangles are congruent. We also have angle, angle side. So if we can prove that angle, angle, and a side, a non-included side in this case, are congruent, then the triangle is. Hypotenuse, leg. Hypotenuse and leg are words relating back to right triangles. Hypotenuse is the diagonal or the longest side and the leg is one of the other sides. If we can prove both of those are congruent, then we have a congruent triangle. We have side, angle, side, an included angle between two sides, and we have angle, side, angle. Sort of an easier way to keep track of this is that there's two combinations that will not work. The first one of these is angle, angle, angle. This does not work. They're not congruent, and I would like to show you why. So if we have an triangle that gets bigger, I want you to see that the angles are still the same. The angles are exactly the same. And there's the third angle. The triangle got bigger, but the angles all remain the same. So just having three angles isn't enough to tell us the triangle's the same, because these are both triangles with the same angles, but they're not congruent. They're different sizes. We also have the angle side side that does not work, or what we call the donkey theorem, and I'm going to feel free to leave that up to you to see what I mean by donkey theorem. This says that if you have an angle, right here, an angle and a side, okay, so we have an angle, a side, and a side that are the same. There's two different triangles we can make. So we can have this triangle and this triangle. For both of those, we have kept the same angle, side, and side. But it didn't give us congruent triangles. It could give us first triangle or second triangle. Because it doesn't necessarily give us one triangle, you can't use it to prove correspondence. So no donkey theorem in geometry. Okay, we want to state which one of these 5 postulates or theorems that we use justifies why these are congruent. Okay, so let's look and see what we have here. We have an angle. It does happen to be a right angle, but let's see if we need to use that. We have another angle, and we have a side. And we have on this one the angle, angle, and side that all match up. So we would be able to say that these are congruent. It would be because of angle, angle, side. Okay. This one we have an included side. We have an angle and then a side and then an angle. We have the same thing in the next triangle. It's an angle. So these are congruent based on angle, side, angle. Okay. We have 2 here that at first glance, don't look like they're congruent, but that's because they're not in the same orientation. Okay, we have an angle, and then a side, and another side. Well, that's the donkey theorem. We don't have angle, side, side. So let's see if we have the other part with angle, side, sides at work, and that would be our special one for right triangles, hypotenuse, leg. We are dealing with right triangles here, so let's see if we have a hypotenuse. Those match up to hypotenuses, and a leg. We do. Our triangles would have to rotate and flip in order for you to have them right on top of each other, but they are congruent based on hypotenuse, leg. Okay, let's look at the next one here. We have a side, an included angle, and a side. We have the same thing on the other triangle. So that is one of our theorems that work. Side, angle, side, and our angles included. So they're congruent because of side, angle, side. Okay. Here you can see we have 3 sides that all match up. And that's congruent due to side, side, side. Our 3 sides would make side, side, side. Okay. I'm going to look at 12F now. Corresponding parts of congruent triangles are congruent. This is in effect the converse of these theorems that we've looked at, the side, 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 and so forth. The converse is what we call CPCTC. Corresponding parts of congruent triangles are congruent. In other words, we use this to show that the angles or the sides are congruent. Okay, given, our first example here is given ABC is congruent to triangle DEF. Name all the sides and angles. Remember, this was easiest to do when we started highlighting things. So we had A and D equal to each other, and then we have B and E, and then we have C and F. So if we look at angle A, it would equal angle D. And angle B would be angle E. Okay? And if we were to look at our last angle, here we could have angle C is the same thing, congruent to angle F. AB, the first and second spots would be congruent to DE. First and second spots. BC would be congruent to EF. And the last spot we would have AC congruent to DF. So we could, if we knew our triangles were congruent, we could say that automatically angle B equals angle E because CPCTC. Okay, let's look at some of our last examples we have here. Find all missing angle measurements if the triangles are congruent. Okay, so we want to know, what does DB equal? So which sides match up? We have C congruent to B. So let's see if we can do some highlighting here. See if that helps us. So we have C congruent to B. Okay, so we're going to have C congruent to B on one side. And we have A congruent to D. So these two are going to match up. And then we're going to have B congruent to C. Okay, so again, these are going to flip, B and C. Okay, helps us think about how it's going to work here. So DB between the green and the yellow would be the value between the green and the yellow, which is 3.4. And AB is between green and yellow. And we have between green and yellow 4.7. Okay. We want to find the measure of angle D, and we also want to find the measure what x equals. So angle C is equivalent to, or congruent to angle B. So we could say that our angle with 32 is equal to x, or x is 32. How are we going to figure out what D is? Because we don't have two of the angles. But on the congruent triangle, we do. We have 46 and we have 32, and we would know that our difference would have to be 102, and that would be the same thing as angle D. Okay, so let's look at ones that get a little bit more complicated. When we get them back, we'll look at them. Okay, what value of x could be used to prove that the two are congruent, and we are told that they are isosceles? So we need to be able to use what we know about isosceles triangles. First of all, if we know we're trying to prove that they're congruent, we want to know what value of x would give us something that would leave these to be the same, because the angles would be the same. We have angle M and angle Q, they're both in the middle, so they would be the same. So what we would do is set up an equation where the expression in our first is going to be equal to the expression in our second. When we went ahead and solved that, we would end up with x equals 4. We're asked what's the value of x. We're going to answer what is the value of x. X is 4. Okay, now we know what value of p could be used to prove this. So we want to know what p is. Okay, we know it's an isosceles triangle, so we know that p and r are going to be the same thing. So if we have a value for q, we can find what p and r are. Okay, what value of p could be used to prove it? So we know that q would be 24. And x plus 24, if we solved that, we'd end up getting 78. Okay. In our last problem here, we have much more information, and also our triangles are not in the same orientation. So we have to do some thinking here about what lines up with what. What's always worked in the past here is to highlight things. M is congruent to P, so maybe we should highlight them on our figure also. Those are the congruent sides, or what we're trying to prove congruent. In the middle we'll have N congruent to R, so we have R and N, and then we're going to have O and T congruent, and those are our values there. Okay, why don't we focus on finding the x first? We want to know what side we can line up with MN. So we have MN, we want to know what it's congruent to. So it's a yellow and a green. Here between a yellow and a green, we have PR, and that was 14, and MN was 3x plus 2. So if you solve 3x plus 2 for 14, you're going to get x is 4. That's part of our answer. What value for x and y is our question. We have part of our answer. Now let's work on y. Y is with the angles, so let's see what's going on there. We have an angle here that's green and one that's green here. So let's see what we can set up there. We're talking about angle N being congruent to angle R. Angle N is shown as 1.5y, and that's equal to 5.1. And when we divide both sides by 1.5, we end up getting y equals 3.4. And just to double check ourselves, we can do the blue angles. There we would have 3y is the same thing as 10.2. When you divide both sides by 3, you will also end up with y equals 3.4. So that's our answer. What is x and what's y?